All right, so here we've got this problem. We want to compute a limit analytically for a complex fraction like this. And okay, so the first thing you should always do when you want to compute a limit is just try plugging in the number and see what happens. So if I plug in x is equal to 4, if I plug in x is equal to 4, I get 0 in the numerator and I get 0 in the denominator. And okay, so that is bad. That 0 over 0 is never an answer. So that didn't work in this case. But there are some cases where it would work. And so that's why it's always the first thing that you should try, because it's the easiest thing to do. And sometimes it works. Obviously, it didn't work in this case, but sometimes it does. So you should always try that first. Okay, so then 0 over 0 is never an answer. And so if you get 0 over 0, when you try to plug in the number, then what that means is that there's probably a way to simplify this. So that's your next job, is to try to simplify this fraction. Try to simplify this so that it is safe to plug in the 4. So that's what we have to do. So basically, that's what this problem is. This problem is essentially, can you simplify this complicated expression? So, all right, well, so let's just try to do that. And when I do these, I try to just do it one piece at a time so that I don't get things too complicated or mixed up in my head. So I'm going to start with 1 over x plus 7 minus 1 over 11. So let's just focus on simplifying that first. So we'll write that as a single fraction. So the way to write that as a single fraction is, well, you need to get a common denominator. And so I can get a common denominator by multiplying the first fraction by 11 over 11. So multiply the top and the bottom of the first fraction by 11. And oops. And then multiply the top and bottom of the second fraction by x plus 7. So x plus 7 over 11 times x plus 7. So you see, I took that second fraction and I just multiplied the top and the bottom by x plus 7. So that 1 over 11 is the same as this, and 1 over x plus 7 is the same as this. And then now I've got a common denominator, so I can combine those fractions. So I get 11 subtract x plus 7 over 11 times x plus 7. And then, okay, and then 11 minus 7 makes 4. So that's 4 minus x divided by 11 times x plus 7. All right, so that's what this numerator expression simplifies to this. Okay, now I'm going to do the same thing for the denominator. So I've got 1 over x plus 1 minus 1 over 5. And that's equal to, okay, so the first fraction, I'm going to multiply the top and the bottom by 5. So I got 5 over 5 times x plus 1. Oh, and yeah, make sure that you're using these parentheses appropriately, because remember, whenever you have a fraction, there are always invisible parentheses around the numerator and the denominator. So when I multiply the top and the bottom by something, it has to distribute over those invisible parentheses. I guess they're not invisible anymore because I drew them, but they always have invisible parentheses. All right, and then we're gonna subtract. Okay, now I have to multiply the top and the bottom of this fraction by x plus 1. So that'll give me x plus 1 in the numerator divided by, and then 5 times x plus 1 in the denominator. And okay, now there's a common denominator. So I can do the subtraction in the numerator. So I got 5 minus x plus 1 divided by 5 times x plus 1. And then in the numerator, let's see, 5 minus a 1 makes 4. So this will be equal to 4 minus x divided by 5 times x plus 1. Okay, so I should have used different colors, but maybe I'll draw a line here to separate these. That here's our numerator expression. Maybe I will use colors. Let me get rid of some of this stuff. I'll use my highlighter here. So this numerator is the same as this. And this denominator is the same as this. So, all right, so that means that this fraction I can rewrite, or this whole limit, the limit as x goes to 4, I can rewrite as 4 minus x over 11 times x plus 7. Because that's the numerator, that's what we said the numerator simplified to. And then the denominator is 4 minus x divided by 5 times x plus 1. Oh, and you remember how I talked about the invisible parentheses? I'm just going to put those invisible parentheses there just for emphasis. You don't really need them, but I like, they might be important. So let's put them there. Okay, so now you got a fraction in the numerator and a fraction in the denominator. And okay, great. We know how to simplify things like that. If you have a fraction divided by a fraction, that's the same as multiplying by the reciprocal of the denominator. So all right, so this nasty fraction up here is actually equal to 4 minus x divided by 11 times x plus 7, and then multiplied by, what is it multiplied by? I gotta do the reciprocal of this green fraction. So multiplied by 5 x plus 1 divided by 4 minus x. All right, and that's really good because look at what we got here. We've got a 4 minus x in the numerator and a 4 minus x in the denominator. So those guys can knock each other out and make 1. So this is going to be, what we got here is we got the limit as x goes to 4 of 5 times x plus 1 divided by 11 times x plus 7. All right, and now what do you do? So now you say, I don't think I can simplify this anymore. If you said, I don't think I can simplify this anymore, you'd be right. You can't really simplify this anymore. So you might say, oh my gosh, we're stuck. But no, but remember what I said. Remember what I said, the first thing you should always try to do when you need to evaluate a limit, the first thing you should always try to do is plug the number in. So let's see what happens. If I plug the number 4 into this fraction, I get 4 plus 1 makes 5, and 5 times 5 makes 25. I get 25 in the numerator, and if I put 4 in the bottom, I get 4 plus 7, that makes 11, and 11 times 11 makes 121. And that's an answer. 0 over 0 is not an answer, because 0 over 0 is not a number. But 25 over 121, that is a number. And that is what the limit is equal to. Oh, and this is a multiple choice question, I think. So I guess I can check, see if my answer's there. Yep, there it is, 25 over 121. I can even check it, make sure, get that nice green flag there. And now I feel good about that. So, all right, so the moral is that essentially these problems are just a simplification problem. Really, the name of the game here is just simplify this expression as much as possible. That's exactly what we did. We simplified this expression, and it turns out when the smoke cleared, this complicated fraction was really just equal to this simpler fraction. And once we had it simplified, then it was safe to plug in 4, and we got an answer. And so when you're simplifying these fractions, just try to do it one piece at a time and just show all your work. And also make sure that you're using parentheses when you're supposed to be using parentheses. Because that's where most of the common mistakes happen, is when you don't use the parentheses appropriately. So get into the habit of always using parentheses. Even if they're not necessary, get in the habit of putting them in there because it'll help prevent you from making unnecessary errors.